Now let's see this example. Given that a relation is having these three attributes A, B, C and only one relation, which means there is only one table, and these functional dependencies, we want to check whether this table is in third normal form or not. Okay, so they are saying that we have A, B, C in one table and the functional dependencies are like this. We are supposed to find out initially what the candidate keys are. Once you find out the candidate keys, then you can understand what are the key attributes and what are the non-key attributes. Why should we know them? Because according to the definition of second normal form, partial dependency is when, see this, when there is a key attribute can determine a non-key attribute, or let us say this is the candidate key. The candidate key can entirely determine a non-key attribute, but if a part of it is also determining it, then that is a problem. That is why you have to understand what are the key attributes and what are the candidate keys, right? So let's try to find it out first. What could be the candidate key for this table? Now if you see this, in the right hand side, C is there and A is there. So A is there and C is there. Therefore, every candidate key should definitely contain B. B is necessary to be present in every candidate key, because if B is not present in the candidate key, it will never be able to determine B, because no functional dependency is able to determine it, isn't it? A candidate key will be able to determine other keys only because of the functional dependencies. If the functional dependencies are not able to determine B, then there is no way any candidate key could determine this if it is not present in the candidate key. Therefore, B should definitely be present in the candidate key. Okay. Now let's see if B is sufficient. B is necessary to be present in the candidate key. Let's see if B is sufficient to be a candidate key. How can you find out? Find out B plus. So if I find out B plus, I am going to get only B. So definitely it is not sufficient, so I have to add something more to that. So let's try to add a minimal thing, let's say A, and let's see whether it is a candidate key or not. BA plus, so or you can call it as AB plus. So what do I get? BA, and because of AB is already present here, because of this functional dependency, since left side is already covered in this, you are going to get C. So everything is covered. So BA can be a candidate key. Now, is it minimal? Yes, it is minimal, because you cannot delete anything from it, right? Will there be other minimal candidate keys? Let's check it. So one is B, A, you have checked it. We didn't check BC, right? Let's see if BC can be a candidate key. So what do you get? BC, and because of C, A is also covered. Therefore, what can you say? BC is also going to be candidate key. So these two are candidate keys because both are minimal, isn't it? Both are having only two attributes. Okay. Now, since BA is a candidate key as well as BC is a candidate key, all the attributes ABC are all key attributes. Got it? So when all the attributes are key attributes, there cannot be any partial dependency. Partial dependency arises when part of a key is determining a non-key attribute, but there are no non-key attributes at all. Got it? Therefore, the table is in second normal form. Now, what about third normal form? If the table is already in second normal form, you can check the third normal form by checking this, whether non-key attributes are determining non-key attributes. If this is the case, then we can say that the table is not in third normal form, but then there are no non-key attributes at all here, so there is no way you can get any functional dependency having this relation. Therefore, the table is not violating third normal form as well, so it is in third normal form also. If you are not able to understand this logic, you can take each one of them and you can check it. See this? Now BC determines C is there. Can it be partial dependency? What is partial dependency? Part of the key should determine a non-key attribute. Now AB is not a part of the key, therefore this is not violating second normal form rule. Now what about this one? C determines A. Yes, left side is a part of the key, isn't it? But right side is not a non-key. Got it? Therefore it is also not violating second normal form rule, which means there are no partial dependencies at all. Therefore it is in second normal form. What about third normal form? Non-key attribute should not determine non-key attribute. Now see this, This is all not non-key, this is all not non-key, all are key attributes only, right? Therefore there is no way we are violating third normal form also. So the table is definitely in third normal form. Got it? Okay.